Welcome to Chapter 4 of the Subaru Lineartronic CVT Generation 1 transmission. In this chapter you'll learn theory and operation for the unit. This will include computer strategy, failsafe, component pinouts, solenoid testing, clutch apply charts, related input and output devices, valve body information, and hydraulic flow diagrams. My name is Jared Warren and I'll be your host for this course. It's a great day to fix transmissions, so let's get started.
Subaru Lineartronic is a continuously variable transmission, providing smooth, more responsive, and fuel-efficient gear changing. Power is transmitted from the engine to the torque converter, which has increased lockup for improved fuel economy, and onto a pair of adjustable V-shaped pulleys connected by a flat metal chain. In fully automatic mode, the width of both pulleys smoothly changes and the chain moves to the optimum gear ratio for the driving conditions. In manual mode, the driver can select one of the 6 predefined ratios using the paddles on the steering wheel to suit their specific driving situation. Unlike other CVT transmissions, the forward and reverse clutches on the Subaru Lineartronic are positioned after the variable pulleys, which also helps protect the gearbox from the torque feedback from the wheels. Smoother gear changing, more responsive, better fuel economy. Subaru Lineartronic.
Thank you, Subaru, for the video. So the main reason for the Subaru CVT transmission was designed to save fuel, also gear ratio control, and improve drivability. Some of the driver's controls include a paddle up and down switches that are located on the steering wheel, and a console-mounted floor shifter. There are 3 modes, basically, that you can select. One basically is a automatic mode, put it in the drive position and you drive like a regular car. You're not going to feel the shift gear changes, you're just going to see a ratio change. Automatic mode provides gear ratios from 2.37 to 1 to the highest range, all the way down to 0.37 to 1 in the lowest overdrive range. Automatic mode is controlled by placing the shifter in the drive position. Also, you have your manual mode, so you put your shifter down in the console over to manual mode, slide it sideways, and then you're able to use your tap up and down switches on the steering wheel to make it feel like a 6-speed automatic transmission, where you can select your shift timing of when you want it to shift to make it feel more sporty. A temporary manual mode is basically, let's say you're on the highway or something along those lines, and you're going into a turn, or you want to slow down going down a hill. You can hit the tap down button, and it'll downshift to a preset ratio, and it'll give you some engine braking and kind of a sportier feel. They also have what is called the X mode. It's basically a new driver assistant system that utilizes all vehicle systems provided to increase traction, vehicle stability, and vehicle control while driving on snow and ice, slippery surfaces. The X mode is only available under 18 miles per hour. In the X mode, you're going to feel hill descend control, which is basically engine braking. It slows you down going down a hill. Stronger transfer case clutch application, so it's going to increase the all-wheel drive or the four-wheel drive. It's in turn the transfer case clutches on. It's going to limit the torque to the engine. Basically, it's going to slow throttle response down on low engine loads, and at higher speeds it's going to accelerate the engine loads quicker. Going to have faster limited slip differential functions. So this is using the whole car as a system. It's making the rear end kind of like a locker. It locks the rear end up also and makes it limited slip. Also, along with the the transfer case clutch, so it's turning it into a four-wheel drive. It's going to change your ratio up, so you're going to have a higher gear ratio from start, so a little less torque to prevent you from peeling out on snow and ice, better control on the ice. You're not going to be able to have cruise control. The X mode operation is in forward and reverse. It will show up on your multifunction display with the X mode lit up. And there's also a HDC light on your multifunction display when it is in effect too. Here are some of the different modules and what controllers are used for the X mode. So like you have your X mode switch, then you have your BIU, body interface module. It sends a signal up to your combination meter, also to your ECM, along with your TCM vehicle dynamics control, and they also have insight or eyesight, which is kind of proximity sensors around the vehicle, stuff that's close to the front bumper, rear bumper, to kind of prepare if you're close to a vehicle, a tree, or something along those lines. So this is the monitor that it is on in the center console, up in the dash. The hill descend light is a vehicle going downhill. It flashes when you're facing downhill when you're in X mode. It shows when that's active. Also, your X mode light will be on, and the right side you see your traction control light when slippery surfaces that could be flashing too when it sees wheels slipping. The hill descend control is automatically turned off roughly at 12 miles per hour, and the X mode is automatically turned off at 18 miles an hour. Now, if you hit the X mode button while you're going faster than 18 miles an hour, you're just going to hear a loud beep, and it's not going to go into the X mode. So here we're talking about some sensitive fails, what kind of drivability problems you're going to occur. So first we're going to talk about your speed sensors. Your primary rotation speed sensor, your secondary rotation speed sensor, and your front wheel speed sensor. If any one of these sensors fail, you're not going to feel any drivability concerns or issues with driving the vehicle. It's still going to drive fine. Your AT light's going to flash. It's going to set a code, but you're still able to have full range of ratio change. Now, if you, let's say, lose power going to your speed sensors, so you lose all three speed sensors, then you are not going to have full ratio control. It's going to start off, feel like you're slipping because you're going to be in a higher ratio, and then once you get going, it's going to kind of stair step the ratio. So that's kind of the limp mode it has for it. If you are in reverse and have to back up a hill with failed speed sensors, you may get a no reverse condition, or the vehicle may not want to move because you're in a fixed overdrive ratio, which may not have enough power for the vehicle to actually back up the hill. Some of the other sensors, the secondary hydraulic pressure sensor. If this sensor fails, sets a code, you're going to have delayed down ratios at coasting, so it's going to not change ratios quickly. If your secondary linear solenoid fails, you're going to have higher engine speeds, no torque converter lockup, engagement shock going into like drive and reverse. Your forward and reverse clutch linear solenoids, if you have problems with those or a solenoid code with those, you're going to feel an engagement going into gear. It's also going to be bind on turns. Your four-wheel drive is going to be engaged. You're going to have higher pressure because of this. More aggressive ratio changes also. If your primary up solenoid fails, you're going to it's going to unlock the torque converter, so you're going to have a higher ratio, and it will also have no ratio change towards the overdrive position. If you have a primary down position, you're going to be in the overdrive ratio, and it's not going to drop down into like first gear feel. So you're going to have very sluggish takeoff. If you're either one of your lockup duty solenoids or your lockup on-off solenoids, you're going to have higher engine RPMs, and you'll have no lockup control, and the information on the scan tool for calculated gear ratio will be incorrect. Excuse me. If the all-wheel drive solenoid fails, you're going to have no four-wheel drive or no all-wheel drive. If your automatic transmission temperature sensor, your AT light will start flashing. Also, it will turn off after you cycle the ignition key on your AT light. If you turn the key on, turn the key off, it will reset itself. You may have engagement into forward and reverse. If you are pointed downhill, you may also have a feel that says no reverse. So it may stick this thing into a higher ratio in the limp mode, per se. Inhibitor switch or range switch, if this fails, you're going to have an engagement problem going into drive reverse. It's going to hit hard. Going to set a code for these, of course. Manual switch, if the manual switch, you're not going to be able to go into manual mode. You're not going to be able to use your tap up and down buttons. If you lose your high-speed communication, you're going to be in a limp mode. Vehicle will feel binding on turns. You may feel banging sound from rear end and transfer case, because the duty cycle is going to go jump from 40 to 100%. You're going to feel some delays on your downshift coasting also too. So to wrap it up, a lot of times you're going to be able to drive these vehicles with speed sensor problems if they all don't fail. Depending on what solenoid fails, you may still get a ratio change. Binding around turns is common when you have codes and also firm engagements. Alright, some of the pinouts, electrical charts, and testing. I'm going to go over that in the next section. I used a 2010 Subaru Outback for this webinar or training. We want to emphasize to pull up the correct wiring diagrams for the vehicle you're working on. These are just for an example. Some of the stuff that I ran into while working on these cars, the connectors can kind of be confusing, because connector, the TCM has two connectors, and sometimes they label them A and sometimes they label them B. So the connector labeled B54 is what is considered connector A, and the one that's labeled B55 is connector B. So on the pinouts, as you see here, you see like A3 and A16. Those are going to be connector B54, and then the pin number 3 or 16, whatever follows the letter A. So now if you're dealing with a connector B, which we'll cover a little bit later, it's going to be a B in the front and then the number of which pin behind it. But then it refers back to the B54 or B55. So here's your pinout for connector A, the B54 connector, and what each wire is for. As you see here, most of this is for your solenoids, your speed sensor information, temperature sensors, TCM grounds. Most of your testing is going to be at this A connector, this B54 connector. Here's the B55 connector, which is the B connector. It's used mainly for your manual mode switch, your data link connectors, powers and grounds. Here's the connectors for your B55. As you see here in the terminals, here's your B55 connector on the TCM, and you see the wiring, B21 or B1. That's for those connectors. And here's the wiring and the connector views for your primary speed sensor and your inhibitor switch. We're going to go over these pinouts a little bit later also to test these components individually. So let's learn how to test the speed sensors. They are all the same way. All three speed sensors are a 3-wire Hall effect speed sensor. They require battery voltage on terminal 1 at the sensor and a ground on terminal 3 at the sensor. The signal wire is terminal 2. It's going to produce a 5 volt to 0 volt square wave signal. The DC hertz will increase with speed. So the faster you're going, the up and down are going to get closer and closer together. The primary speed sensor measures the speed of the primary pulley. So over here on the left, you see pin 1. It's going to be your battery voltage. This is looking into the connector view here. Pin 1, so those match up. That's battery voltage. 3 is your ground and 2 is your signal. Location, the primary revolution sensor is basically on the passenger side of the transmission up towards the front of the bell housing. Right underneath that we have your secondary oil pressure sensor. Now your secondary pressure oil sensor is also a 3-wire sensor. This runs off of 5 volts on terminal 1. Ground is terminal 3 and the signal is terminal 2. Signal on terminal 2, if the engine's off, then the key is on. So we have zero pressure inside the transmission. You're looking idling with no load, with the engine running, you're at 0.5 volts. Engine stalled up, you're going to be at 0.45 volts. So the way this sensor goes, the higher the pressure, the higher the voltage. Now on to the other sensors. Again, they operate the same way, same pinouts. Connectors are a little bit different on them, so you can't get them mixed match plugged in the wrong place. Front wheel speed sensors here on the very bottom. It's in the tail housing. It is where your front wheel speed sensor is reading. It actually reads off the transfer gear that goes to the front differential. Your secondary revolution sensor is right basically in the middle of the transmission here. It's kind of buried by some wiring for the main wiring harness kind of runs over it, so it hides a little bit. And then the other thing I'd like to for everybody to pay attention to, up by the connectors themselves, there's some single ground wires, some that come out of the connectors and some that go to the transmission case, and then the transmission case to the body itself. Make sure these ground wires right here are hooked up and are in good shape, especially if you have some solenoid codes or circuit codes. We have found many of these corroded, many of these wires broken. Alright, the range switch, or inhibitor switch as some people call it, is mounted on the passenger side of the transmission. I have found it easiest to test the range switch, the T3 connector. This T3 connector is up here on top of the transmission. It's black in color on the right hand side here. Your range switch is right here mounted underneath the shield. And your T3 connector is blown up here on the top left. So if I was to check the range switch at the T3 connector, which I found it easiest when especially working on the car, I'm going to put 1 mm on pin 4. As you see in the chart here, pin 4 is common for all 4 positions. And then I would check for which lead in the corresponding position. So 4 and 3 is going to be for park. Make sure it has continuity. 4 and 2 for reverse. Neutral is going to be 4 and 1, and drive is going to be 4 and 8. And of course, if you want to check your starter neutral switch, pins 12 and 11 should have continuity in park and neutral. And backup lights are pins 10 and 9. That's all the terminals that I just listed are all from the T3 connector. If you want to do it from the range switch, you can also do that at the range switch. I got the connector view and the range switch view here on the bottom left and on the chart in the top right. Alright, so down in the valve body you have a connector here. The connector is on the other side of the valve body, and it basically houses all your solenoid wires here. A couple things to note. A lot of these ground wires in here, the ground wires are connected to these solenoids and they're connected to the valve body. So to connect and check your solenoid, you're going to have 1 meter on the valve body itself, then the other one to the solenoid you're testing. So if you're testing like the secondary solenoid, you would want to be on connector 1 or pin 1, and then the other lead to the valve body itself, you should have 5 to 7 ohms. Forward and reverse, you'd be on pins 3 and ground. You're looking at 4 to 6 ohms. The lockup on and off is pin 5 and ground. You're looking at 15 to 17 ohms. Then for your primary up, down, and lockup duty cycle, you're all looking at 10 to 13.5 ohms. And then your all-wheel drive solenoid, you're looking 2 to 4.5 ohms. Over here on the right, also I'd like to mention the wire colors to where the solenoids go here. So the gray and the light green wire is for your lockup duty solenoid right here. When you pull these solenoids off, it's kind of easy to get them put back into the wrong position. So I always like to go by the wire colors because the solenoids don't come off the wires easy at all. You actually have to disassemble the solenoid to get the wires off the solenoid. You can do it. It is quite hard to do though. This is a T4 connector. Back up one slide here, or 2 slides. T4 connector is this gray one right here in front of the T3. I should have got a picture of the T4 and put it in on this slide. Sorry about that. But T4 is right next to the T3. This is where you're going to check your resistance of the transmission sensor. The transmission sensor is built into the internal harness inside the transmission. And you can check it at pins 19 and 16 at the T4 connector. Let's see, 19 and 16 is for your temperature sensor. Where's the ohms reading? Here we go. You should have about 2,500 ohms at 68 degrees. And you should have 330 ohms at 176 degrees. So as temperature rises, your ohms is going to drop. The other thing you can check at your T4 connector, this gray connector, is your solenoid resistance. So you can go to ground, and you can go into each one of these wires to get your solenoid resistance up on top of the transmission if you don't want to pull the pan to check it inside. There are a fair amount of problems with the connectors on the top of this transmission, so it's always a good place, in my opinion, to start looking at those connectors and the grounds on the top of the transmission for any electrical issues. Clutch supply chart. I got to say, this is probably the most simplest clutch supply chart, besides maybe a Honda. Is pretty much, they're tied. Input clutch. As soon as the engine RPM is around 200 to 400 RPMs, it automatically applies the input clutch right off the pump. We'll talk about the input clutch a little bit later, but it's applied off the pump. Nothing else controls of it. If you want to go forward, it turns on your forward clutch. If you want to go in reverse, it turns on the reverse clutch. If it needs four-wheel drive or the transfer case clutch comes on for four-wheel drive. It's that simple. There are a lot of different case ports and tubes in this unit. A lot of different O-rings laying around that need to watch out for. We'll cover that in the rebuild section. But I have some ports here labeled for you for some air checks, that kind of stuff. To do your air checks, for the most part, the transmission has to be assembled, especially with your the way, like the reverse clutch over here on the left side. Your reverse clutch is fed through the center of the case and goes into the rear extension housing. You can air check it right here at the reverse clutch, but I also recommend you checking it over here at the case once you get it all together and make sure some of the O-rings are good. Same with the transfer case clutch. That passage there has an O-ring on it. Same with the reverse, has an O-ring on it. And then you can check your transfer case over here on the right. Primary and secondary pulleys. Not a big fan of air testing the primary pulleys. The main thing is you have to pull these pulleys apart to check them. Over here on the left, we're looking inside the front of the bell housing. There are O-rings to seal the ports on the secondary pressure, the torque converter apply port. There's also a sealing ring on the lockup release tube. And then on the other side of the bell housing, we have your converter on pressure, your converter pressure. This aluminum shaft here has two O-rings on it, one on each end. Your secondary pressure has an O-ring on it also. And as we were talking earlier in some of the previous chapters, differential fill. Here's the fill spout hole. This is the oil check level. and this is the drain plug for the differential. Let's talk about some solenoid operations. Solenoid control is a little different. In this unit there is no shift solenoids for predetermined gear changes. It uses the primary up and the primary down solenoids to control the ratio. Secondary linear control solenoid is the main solenoid that controls the pressure. And for the lockup you have the on-off solenoid and the duty solenoid for lockup slip. And then you have your transfer case clutch solenoid, and it controls the all-wheel drive. Here's a graph of the primary up and the primary down solenoid. As you notice here, you see this solenoid is on till about right here, and you go to the other solenoid, you notice it's off until that point. So either you're going to have a primary up or you're going to have a primary down solenoid being controlled, but you're not going to get both of them controlled at the same time. So all these solenoids are feed controlled by the TCM, so it's sending power to the solenoids. The solenoid themselves are grounded at the valve body. The valve body is grounded to the case. The case has to be grounded to the battery. So vehicle grounds are very important on this vehicle. So the secondary linear control solenoid is a linear style solenoid. The lockup duty, primary up and primary down solenoids are all pulse width modulated solenoid. These solenoids are normally closed and fully interchangeable. The lockup on-off solenoid is the only on-off style solenoid. It's normally closed. This is an interesting solenoid. It controls the pressure to the pulleys to keep the chain tight enough that it does not slip. The secondary pressure can be as high as 900 psi. The main regulator for this transmission is built into the snout of the solenoid. So the main pressure regulator is not in the valve body, it's actually in the snout of the solenoid. Pump pressure enters the end of the solenoid snout. We've removed the valve from the snout to show the orifices A and B. Orifice B is behind the screen on the valve. So right here under B, you have a screen underneath, or you have a hole underneath the screen here. There are two balance orifices built into the valve. Orifice A is the balance orifice for the main regulation and keeps the valve balanced, like most normal pressure regulator valves. Orifice B is a little unusual. It is controlled by the solenoid. The solenoid acts on a needle and seat that opens and seals this orifice to control the position of the solenoid regulator valve. The secondary linear control solenoid operates at 2000 Hz. It's very fast. So what basically happens is there is a seat that is plugging off this B orifice right here, which controls the flow of this valve and the regulation. Alright, so we got the valve body taken down. We're going to go over some of the upper valve body control. Upper valve body, you have your forward and reverse control, your TCC, your all-wheel drive, and your torque converter valves. So now if you are dealing with, let's say, a lockup issues we need to check valves 2, 3, and 4. So 2 right here, this is your TCC solenoid pilot. Number 3, this is your TCC control valve line up here. And number 4 is your TCC control valve. If you have a shutter around turns and basically we're going to need to inspect the all-wheel drive. This could be an all-wheel drive solenoid. It also could be your all-wheel drive control in number 7 right here. Check and make sure this bore is nice and free. Valve is free. Make sure this plug is tight and no leaks on the end of it. Now we're going to go to the upper valve body, the small parts on it. So in the upper valve body, there are three filters with springs. The springs go in first, and then the filters on top. We have 3 springs and blow-off valves. Watch out because the valve and springs are different sizes. This one labeled B right here is the oddball. So A and C are the same. B is a little bit longer right here on the valve shape is longer, and it has a weaker spring than the rest. Your spring sizes are down here on the bottom. Excuse me. Alright, so on the lower valve body. In the lower valve body, we have some secondary regulator valve, TCC boost and regulator, and the primary control valves. So number 14 here, which is your TCC boost and regulator. Make sure this sleeve is not worn out. The metal boost valve and sleeve is not worn out. We have seen some signs of wear there. At this time, I don't know of any replacement parts. Your primary up is number 12 here. So if you have a problem with ratio change up, you may want to take a look at number 12. Number 9 is your secondary regulator valve up here. And number 13, this one is your solenoid regulator valve. It likes to get worn out too. Okay, so for pulley operation. So as soon as we start the engine, we have secondary pressure pulley, secondary pressure, putting pressure inside these pulleys. So secondary pressure is your red. It's your high pressure. As you see here, the red cylinder is going to shove down, shove in. This blue here is fixed to the shaft. So when oil pressure gets in here, it's going to shove this pulley down right here. This outer sleeve is movable and tightened down on the chain. On the other side, red pressure goes down the pulley out here, and it shoves this section of the pulley tight. So this is equal amount of pressure on each pulley, squeezing tight on this belt so the belt does not slip, so it doesn't chatter, that kind of thing. So we got secondary pressure keeping the belt from slipping. So the next thing we need to talk about is how does it change the ratio. So we have primary pressure ratio control. Right here is the green going in. So what the green oil is going to get in here to this chamber here. It is going to add additional pressure to your primary pulley. So if it squeezes or puts more pressure in there, it's going to squeeze this pulley together more and force the chain out. When the chain's forced out, it is making this pulley move itself. So we only have one side of the pulley that gets the primary pressure, and that's how it is used to control the ratio. So it's adding and subtracting a different, I'm going to say piston or different chamber in the pulley on the primary pulley itself to get your chains to move up and down. Alright, so you have your primary up and your primary down duty solenoids. Right here, primary up and primary down duty solenoids. They control the position of the primary flow valve. The primary flow valve controls oil to pressure to your change. This is what is changing your ratios. So just remember, primary down drains oil from the pulley. Primary up adds oil pressure to the pulley. Now we're going to talk about lockup operation. Lockup main system components are the two lockup solenoids, the switch valve, and torque converter. And I'm going to say switch valves and regulator valves. First, the solenoid controlled is the on-off solenoid first. It moves the switch valve. And then the other solenoid is your duty cycle solenoid. This is the one that changes the amount of pressure or the amount of slip of the converter. So the lockup duty solenoid controls the lockup regulator valve, which controls the amount of slip in the converter. The forward and reverse linear control solenoid provides a controlling pressure that moves the forward and reverse control valve. The forward and reverse control valve regulates the pressure routed to the manual valve. The manual valve delivers hydraulic pressure to the forward clutch in the forward shifter position and the reverse clutch in the reverse position. So basically what it boils down to, your linear solenoid is controlling the regulating forward and reverse engagement valve, and then whichever position your shifter's in is what clutch is going to be on. This will conclude our Chapter 4 on theory and operations for the Subaru lineartronic CVT Generation 1 transmission. We want to thank you for participating in our vehicle training solutions powered by ATRA. Until next time, let's keep fixing transmissions together.